Hello. In today's talk, we're going to look at the concept of vision and what it means to be able to see. Vision arose very early in the animal line. In fact, this creature, which is an imprint of a fossil found in Scotland, is 420 million years old, and it already has a well-developed visual system. As soon as you have eyes, as soon as you're able to detect light, you can orientate it to it. So you know where the sun is or the moon. It also means that you can start locating the things that would either like to eat you or that you would like to eat. So from the very early times of the animals, they had eyes, and they developed eyes very rapidly. And my eyes, which are at the front of my head, tell you a lot about the sort of creatures that we are and what we do. When you have two eyes facing forwards, you're either a predator, so you're able to judge distance, or you're swinging through the trees or in an environment where there's a lot of three-dimensional processing to go along so that you don't bump into something or misjudge a branch that you're going to swing from. So in creatures like this cow, they mainly live with their heads down, chewing grass, and their occupation is that they're not going to be eaten by something else. Grass doesn't move, they know it's always down by their feet, so they are adapted to look sideways. And if you ever are close to a cow or a horse or any of these other large grazing animals, you'll see that their pupil is almost elongated into a rectangle, so that they get a huge visual field out of the sides of their heads. Now, in this particular cow, you can see that it does have some overlap, so to be able to see what's in front of it. But with creatures like this beaver, the eyes are slightly smaller, and they're definitely looking out at the side of their skulls. They have very little forward vision in comparison to the things that might eat them, such as a dog or a wolf or a fox. They, like humans, have got a good visual system that points forwards, so they're able to judge distance and know how far they have to crawl without being seen in order to launch an attack. Birds like this owl are classic hunters with their eyes in front of their faces pointing forwards. And even in animals like this kookaburra, where you look at the side and think that they're looking out of the side, so they've got good peripheral vision, when you turn it to the front, you can see that the face is narrow and thin, so they're able to look forward as well. Now, we have camera eyes, which means we have a retina, and there's a lens in front of it which focuses the light, and in front of it is our pupil, which is the aperture, which changes in order to vary the amount of light coming into the eye. And in other animals we have similar systems, and we have less complicated ones. So the creature that lives inside this shell, which is the nautilus, if you can imagine a multi-tentacled squid-like body coming out of this, they have very simple eyes compared to ours, which would be like a pinhole camera, so they don't have a lens, and they have a very reduced form of image that they can process. But they live in the deep sea, they very rarely come up to the front, so that amount of vision is enough for them. The other major type of visual system that we have are the compound eyes. And we have some unusual creatures here with them which we don't normally see. So this horseshoe crab has two compound eyes on the side of its face. It also has a number of simple eyes located at various parts of the body. And this is the only member of the group of arachnids, so the chelicerates, which actually have compound eyes. All the spiders and harvestmen and mites and ticks and so on just have simple eyes. Perhaps one of the most complex eyes in the animal kingdom belongs to the mantis shrimps. Now they have compound eyes, as you would find in an insect, or other crustaceans like crabs and crayfish. But in these creatures, they have 12 optical pigments, so they're much more receptive to different wavelengths of light than we are. And they also have a band of special cells which detect polarized light. We cannot know how a mantis shrimp perceives the world, except that it would be like going from a very simple black and white TV to an ultra high definition one for us. So the positioning of eyes and the capacity for processing visual information depend on the ecology of the animal and what it's used for. Even some of the simplest creatures like box jellyfish have quite a dramatic visual system. We're not quite sure what they use them for, but they are a very dominant, difficult predator, and you don't want to swim with them when they're swimming towards you. So that's the visual system, and now there are other videos to look at.